we were looking at cost forecasting methods, eh?
Yes, yes.
Okay, the last one we looked at was simple linear regression, eh?
Yes.
All right. Did we finish or there was unfinished business?
We are doing May 2017. I think we finished.
We finished, eh?
Yes, regression.
Regression analysis.
Yes.
Sorry?
Yes, yes.
Now we move to another method.
Yes.
All right. So allow me. Yes. Now allow me to move to what we call learning curve. It is one of the methods that we listed, right? Learning curve, sometimes called non-linear equation. Non-linear equation. Let's look at that. It is one of the methods that we listed on how to forecast the cost of a particular product. Are we there, Abdi?
Pardon?
Hello, Abdi?
Pardon?
Karo, are we together? Are you getting me clearly from your end?
Yes.
Now let's look at this particular cost forecasting function, which is called non-linear equation or learning curve. So, to just explain the concept behind learning curve is that when an individual, you are introduced to a particular task for the first time, you tend to take more time and produce less units. Reason being, you don't have experience, you don't have confidence. So that's why you take more time as you produce less output. But if you do that job repeatedly, maybe for example, 6 months, you tend to gain experience as well as confidence. In that case, time will be reducing to produce subsequent units because you have gained experience, you have gained confidence in that particular area. Are we together? Are you together, Abdi and the company? Perfect. Good. Now, let's introduce ourselves. Let's introduce ourselves to that particular area. So we can say when a task is manual, when a task is manual and repetitive in nature and performed by the same individual or group and performed by the same individual or group and performed by the same individual or group, it has to be observed that subsequent jobs will take lesser time. Subsequent jobs will take lesser time. Subsequent jobs will take lesser time on average than earlier jobs. On average than earlier jobs. On average than earlier jobs. This is because of experience and confidence attained. This is because of experience and confidence attained. This is because of experience and confidence attained. Therefore, learning curve portrays an inverse relationship. Learning curve portrays an inverse relationship. Learning curve portrays an inverse relationship. An inverse relationship between average time and cumulative units. Between average time and cumulative units. Between average time and cumulative units. Good. So, heading learning curve models. Learning curve models. Learning curve models. So you say there are two types of learning curve models. There are two types of learning curve models. There are two types of learning curve model. Number one is total time model. Total time model. Total time model, which we say it is y equals to a x raised to b plus 1. Then 2 is the average time model, which we say y bar, that is average, which equals to a x raised to b alone. Ax raised to b alone, like that. That is what we mean as the average time model. So we have those two. So you can say where, why, that means it is total time or cost. It can be total time or cost. Total time or cost. Then we have another one there is Y bar. That is average time stroke cost. Then we have A, time stroke cost taken to produce the first unit. To produce the first unit. It can be time or it can be cost to produce the first unit. Then we have another one there is X, that is the output level. Then we have another one which is very, very paramount, B. This is, we call it learning index. It is called learning index. And how do you get it? So this one will be gotten by logarithm of learning rate divided by logarithm of 2. How do you get that learning index? You say it is the log of learning rate divided by the log of 2. Learning rate, or sometimes called improvement rate, varies from one individual to another, which is very, very practical. We say that we are not all equal. We have fast learners, we have remedial, and we have slow learners. So we are not equal. So it depends in that particular company how the employees grasp information, grasp work experience. Now, there are those ones who are very fast, there are those ones who are slow. So you can be given that, you can be told that in a given firm, the learning rate is 80%. Learning rate is 75%. Learning rate is 90%. Or the learning rate is 60%. So you need to understand that learning rate varies. We together? Mudama? Karo? Good. All right. So that is the concept of learning rate. And at that point, you can be told sometimes to use a graph to explain the concept of learning rate. So the concept of learning rate, I can give an explanation here. That is the going like that. So we have the x-axis and then we have the y-axis. So y-axis, there is time. We abbreviate time. X-axis, we abbreviate units, output. units or output. And therefore, as we said, you do that particular job more frequently, you gain experience, and therefore the time will be reducing as more units are produced. So the curve will be like that, up to the it reaches a point, it is parallel to the x-axis. That is the point we call point of stability, where learning stops. Learning stops. You are now a veteran. You take constant time. Given a job, you know this is the time, or this is the time I'm going to utilize. There is no more learning. It is now you are a veteran. That's why it is parallel to the x-axis. But before you hit the veteran area or vibrant, you will be reducing time and units increasing. That is the inverse, as opposed to linear. Linear is straight like that, but this is non-linear. That's why we say there, it is also called non-linear equation. It is not as the units produce, output also produces, or as the cost increases, output increases. That is what we call linear. But for non-linear is the learning curve concept. Like that. So you can even draw that. Draw that one, sketch. If you are told to use a diagram, that is how you explain. Then you ensure that that point of stability, it is denoted by K. K is the point of stability. Point of stability. So that is how you can depict a learning curve diagram. Good, 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 good. Hope you are clear now there. Now, allow me to have some of the example. You say, consider the following example. Consider the following information. Consider the following information. Consider the following information. A is 750 hours. A is 750 hours. R, that is the learning rate applicable in that particular company, is 95%. 95%. 95%. Then you are required. You are required. Time taken, that's Roman 1. Roman 1. Time taken to produce. Time taken to produce. Time taken to produce 50 units. Time taken to produce 50 units. Time taken to produce 50 units. Roman 2. Average time. Average time to produce 50 units. Average time to produce 50 units. Average time to produce 50 units. Roman 3. Time taken to produce units. Time taken to produce units. So Roman 1, we have said it is Y 50 units. Roman 2, it is average 50 units. Average, meaning Y bar. Roman 3, time taken to produce Time taken to produce units. Time taken to produce units 21 to 30 units. Time taken to produce units 21 to 30 units. Roman 4, average time to produce units 21 to 30 units. Average time to produce units 21 to 30 units. Roman 5, the last one, time taken to produce 30-second unit. Time taken to produce 30-second unit. Time taken to produce 30-second unit. So let's try to carve that particular solution. If it is total time, you use the total time model. So first of all, let us get the learning index. Let us now start solving learning index, which is B. B, we have said it is log learning rate, which is R, divided by log 2. So that means you take logarithm of 95%, which I can say it is 0.95 divided by log 2. So somebody perform that arithmetic, you give us the learning index. Caro, not yet, Caro, I disregard that. That is, you from your calculator, you just found logarithm. There is that button for logarithm. Abdi Bado. Maybe you have already, let me have mine. 0.95 divided by log 2. Abdi Bado, confirm again. Hakuna mwenye amepata. Logarithm, the third button, log 0.95, that is log 95%, log 0.95, divide by, the third button for dividing, divide by, again, log 2, equal sign. Confirm? I'm waiting, confirm. If you can see, you can have the same figure. Hello, this more arithmetic. Yes, now you are talking. Caro. What about Abdi? Abdi, I'm waiting for you. Or you don't have a, yes. Now we are talking now here, it is negative 0.07. Even 74. 0.074. So have negative 0.074, like that. Good. Now, having gotten that, we can come up with the total time model. So, total time model. Total time model. Y equals to A is unknown, X is unknown, raised to B plus 1, which will be Y equals to AX raised to negative 0.074 plus 1. Coming to Y equals to AX. What is the power? Add 1 to that particular negative 0.074. Add 1 plus 1. You will convert into total time model, giving us I have to raise to 0.92599, can even be 6. That is the total time model. What about average? Average. Y bar equals to AX raised to negative 0.074. That's how you're supposed to write those particular models. So that now let us answer our question. Let us answer our question like that. Good. Thank you, Abdi. Is that figures okay? All right. Now let us solve the first one. Time taken to produce the 50 units. So Roman 1. Time taken to produce the 50 units, meaning Y 50 units. What will be the time to produce the 50 units in lump sum sorting? You use this model, the time total time model. So let us have the figures into that particular model. A is time taken to produce the first unit, the very first unit, which we said it is what? 750. 750. So I substitute in this particular equation. So it will be 750 into how many units? 50. Raised to 0.926. 0.926. How many hours are those? How many hours are those? How many hours are those? So just do that arithmetic. Do the arithmetic. We get the number of units, the number of hours, 50 raised to 0.926. So equals, I multiply with, how many hours are those? Try to calculate. How many hours? A good, a B, like mine, 28,074. That is it. 28,074 hours. Mudama, umepata hivyo? Thank you. Now, Roman 2 is the average time to produce 50 units. Average time to produce 50 units. We have the model here. Let us plug the figures. So y bar 50 units. It would be time taken to produce the first unit. It is the same. That is 750 into 50 units of them, but raised to negative. Raised to negative 0.074. What would be the average time? What would be the average time? Confirm that averagely, meaning per unit, I will be taking how many hours? How many hours are those on average? Sawa kabisa, Abdi amepata pale. What about Mgama? Good. That is it. Now we are together. We are together 100%. So here I have 561. Even you can have that 561 hours. 561 hours. Good, good. Or let me give you another alternative way. Alternatively, y bar 50 units. I can take total time to produce 50 units, which is what? 28,074. But I need on average. So what if I divide by how many? 50. 50 units. I divide by 50 units. I must get. Confirm? Is it okay? Is it the same? And if that is the case, have you gotten the concept on Ritter away? This the second one, we call it Ritter away. The second we call it Ritter away. The first one is using the formula. Okay, thank you, Abdi. All right. Now let's go to Roman 3. Roman 3, you are told time taken to produce 21 to 30 units. 21 to 30 units. Time taken to produce 21 to 30 units. That is Roman 3. Why 21 to 30? My good students, here we are accounting for 21 to 30. 21 to 30. Meaning, I'll take total time to produce 30 units minus total time to produce how many units? So that I can get 21 to 30 to just try. First of all, you take total units, total time to produce 30 units. Then you less certain number of units, the time to produce certain number of units, so that I can get 21 to 30. Try. So I get total time to produce 30 minus total time to produce. Just give a try. Members, try. Kemboi, team Kemboi. Try. Abdi. Okay. You take total time to produce 30 units, you less total time to produce 20 units. Because the 21st is also included in my analysis. I want 21 to 30. So therefore, I'll take total time to produce 30 units. I less total time to produce 20 units. Is that point clear? Is that point clear? Now, plug the figures to the formula. Plug the figures to the formula and get the time. So in that case, you can, because A is common in both. A is common in both. And now I can say, because in sometimes you can work separate. But in that case, we have common parameter, which is A. So in that case, I'll say 750 into 30 raised to 0.926 minus 20 raised to 0.926. That is how you can do it. That's how you can do it without wasting time or without doing separately. So try to calculate that. Try to calculate what will be the time. What will be the time? Confirm, bring the time. So members, you are getting what time there? 54:75 or 6. Carol, thank you. That is very Okay, so there we have 54.76 hours. Good. Roman number 4. Roman number 4. Average time to produce 21 to 30 units. Average time to produce 21 to 30 units. Now listen and listen carefully. When you have been given the cumulative time like this, units, that is cumulative units, 21 to 30, and you are told to determine the average, don't use the formula. Don't use the formula. Because if you use the formula, you'll get negative hours. And practically we know that we don't have negative hours. We don't have negative hours. So that means you use the literal way. You use the literal way. How do you use the literal way? You'll say, so here, time taken to produce 21 to 30 units. You take total time. (21 to 30) divided by the difference, which is 30 minus 20 units. Is that point clear? You can only use the average time formula where you have lump sum units. Huh? I'm saying Mudama, is that okay? Okay. Welcome. So I was saying, when you have been given this particular cumulative units, 21 to 30, total time, you take 30 units, hours to produce 30 units, minus hours to produce 20 units. Not 21, it is 20 units, because the 21st is inclusive. We got that. Average time to produce 21 to 30. If you use the model, you will get negative hours. That one, I guarantee you, you can try at your own time. Using the model, you will get negative. So therefore, you just use the normal thinking or the literal way, meaning you take that time to produce 21 to 30 ambao ndio hii tuko nayo hapa. Then I divide by the number of units between 21 to 30. And hapa hapo ni 30 minus 20. So that one will give us what? Will give us, we take 54.76 divided by, the difference is 10. How many hours are those? How many hours are those averagely? That gives us 54.7.6 hours. Are we together? I've told you when we have the cumulative units, use the literal way to calculate the average time and not the method. Good, good. Together, Abdi? Together, Abdi? Abdi and Mudama, are we together? About Abdi? Taking long to respond? Now, let's look at the last one. Total time to produce 30-second units. That is number 5. Total time to produce 30-second unit. Total time to produce 30-second unit. 30-second unit. Total time to produce 30-second unit. My good students, this is the only 30-second unit, meaning only one unit, 30-second unit, and not 32 units. It is not 32 units, it is 30-second unit. That is one unit at the 30-second. Here we go. You take time taken y 32 minus y 31. That is the difference. That is the difference to get the 30-second. To get the 30-second. Again, you can say 1 time taken to produce 15 units. This one is you take total time to produce 15 units minus total time to produce 14 units. Hope I'm clear. Hope I'm clear there. Carol and the company, is that okay? To get the 30-second, you take 32 units in total, you less 31 units in total, so that you can get the 30-second. Chat me if that is okay. If that's okay. If that concept is clear. Good. Now, let us have our time taken to produce 30-second, so that we can determine what will be that particular time for 30-second. So therefore, time for 30-second should be equal to total time 32 minus total time 31. Total time model ndio iko hapa. So plug the figures in the formula. So this one will be equal to time taken to produce the first unit 750 into 32 raised to 0.926 minus 31 raised to 0.926. So what will be the total time to produce that particular unit 30-second? Let me compute. Try to calculate what will be the total time. Carol? Five 37.75. Mine, I'm getting 538.02. Repeat again. Mine, I'm getting 538. Hours. 538 hours. Yeah, that's okay now. That's okay. That's okay. Now we are in consensus. We are in consensus. Now, having done that, having done that, now allow me to give you a question here. I think it is from 2017 May. Let me see. 2017, let me see. May 2016. May 2016. Question number May 2016. Question number 1C. Allow me to grab this side so that I can write the question there. May 2016, question 1C. Try to access that. Try to access. Try to access it and attempt. Try to access and attempt. Members, have you attempted that question? Carol? Okay. What about Abdi? Abdi, where are you? Now, let us compare notes. Let us now compare notes. So here, go compare notes, we compare notes. Good. So they are saying now the total amount of hours required to build the 40 units. So we start with that Roman 1, whereby they want Y 40 units. And I know the total time model. So first of all, let me get B. B is log R divided by log 2, which gives us logarithm. Here, the learning rate is 75%. Logarithm of 0.75 out of logarithm of 2. You got to be negative. Let's see. You got negative what? What will be the learning index? Negative 0. Yeah. Thank you, Carol. Negative 0.415. So having done that, we can now get our time taken to produce the 40 units. Which will be A x raised to B plus 1. So what will be my B plus 1? B plus 1. It is negative 0.415. I add 1. So that total time. So in this case, add 1 to be 0.585. You can even use that. 585. At that point, we can now put our time taken to produce 40 units. Time taken to produce the first unit, I was told it was time taken to produce the first unit, 700 hours into 40 raised to 0.585. Did you do that, Carol and the company? Did you do that? Did you do that? So how many hours are those? Good, good, good. Perfect. So how many hours are those, Carol? $60, 58. You can say 58. 60, 58 hours. Number 2, Roman 2, average time. Average time. Average time. How many average how many hours did you get for average time? Caro, how many? How many hours for good? Be good, good. You use the formula or literal way? Both any can do. Did you use the literal knowledge or the formula? I told you that is in lump sum, any can do. Karo, ulitulitumia gani? Formula. Good. That is it. Because the units were not cumulative. It was lump sum. What about Roman 3? Roman 3. They are saying, assuming that a worker works 28 hours per year. Determine the number of workers that should be assigned to this contract to complete it in a year. How many workers did you get? How many workers? Thank you, Tharo. So let us do together. Let us do together. What about Abdi? So Karo here, we are told, assuming that a worker, meaning one worker, works for 28 hours. How many workers that should be assigned to this contract to complete it in a year? This particular contract of ours, which has 40 units to be completed, we computed to take what? 60, 58 hours to complete in a year, meaning 40 units for the whole year. So here you just come and say, how many workers? Because the job requires 60, 58 hours. So you cross multiply. What would be the number of workers? That is what was required. They are very easy. Just general knowledge. Just general knowledge. Is that point clear, Carol? Sawa. So compute how many workers. So there I have 60, 58 divided by 2080. 2.9. 2.9. So that is 60, 58 divided by 2080, giving us 2.9125, which is approximately 3 workers. Point clear? Is that point clear? Sawa. Good. So that's how you are do that particular question. And that's all about that. Allow me to give you assignment. Zenye utafanya before we meet. You try for me November 2018, question number 5C. November 2018, question 5C. So you try November 2018, question 5C. So you try that one, my good students. So at that juncture, we stop there until next meeting. So I believe we were not able to meet on Sunday in our last meeting. I don't know whether how is your availability so that we can plan for a makeup? That makeup, maybe we decide to make it up or on Sunday. We can do 3 hours. So meaning we start earlier. How do you see? Karo? Abdi?
When will you start? Yeah.
Sorry?
Sunday we have our class at
Sunday we have a class at starting from 8. Is it 8?
8. How will it be possible to have 3 hours from 8 to 11?
Meaning that we can schedule earlier, starting from maybe around 7.
We have from 6 to 8, we have another lesson. Triple A.
From 6 to 8.
We have triple A.
Triple A, 6 to 8. 6 to 8. Mine we are starting at no more.
8.
At
8 to 10.
8 to 10. And triple A?
From 6 to 8.
Or 6 to 8. So. What about backwards from 2?
From 2 to 4.
Yeah.
What about the other? I'm okay with that.
What about Karo?
You want to start from 2 or?
Yes.
From 2 to 4.
Yeah.
It's all right.
Perfect. So I'll talk to admin, but wake up from 2 to 4. That's on Sunday. I take you the class we lost, and then no more again from 8 to 10, so that we try to reduce this workload, because we have some topics like 8 topics. Is that okay?
Yes.
No. Okay, thank you. Thank you very much. Now let's stop there. Let's stop there. We meet in the next, that is on Sunday. We have a double. That is in nutshell, it's a double, meaning it is from 2 to 4. And then you go to triple A, then we come back at 8 to 10. Thank you very much. Thank you very much for taking your time. And in that case, we shall be having breaks. We shall be having breaks. Thank you very much. Have a good night. Bye-bye.